Hello. Yeah, hi, good morning, everyone. Can you all hear me? Hi, good morning, Raghu. Good morning, Madam. Good morning, Ashutosh. Hi, Sahil. So I think we'll start in next 2-3 minutes. The people are still joining in. So let's just wait for the other participants to sign in and join the session, and then let's get started.
Hello, Amit.
Hello.
Hello. Yes, actually, GoToMeeting is updated, but my keyboard is not working in chat box.
Keyboard is.
Yeah, I'm trying to typing, but it's not working.
Don't know. I mean, should not be a reason. I mean, please check. Like you have chosen send to everyone.
Yes, entire. I'm selecting entire audience.
Okay. Still, it's not working.
No, no.
Just try to join in again if that works. You'll send and
Okay,
just
I will.
yeah,
Okay, I'll try.
sure. Okay, so class, did you all give it a shot? Did anyone complete this credit card case study? Like in the last session, what we did was we completed the EDA part, and I asked you guys to try to create a model on the same. Uh, was anyone able to create it? Okay. Yeah, Rishabh, I'll just explain you what scaling function is. See, so first of all, my first question is, so Rishabh, are you clear with the thing like what exactly scaling is? What do you mean by scaling? What is the use of the scaling feature that we have? Okay. So let me try to give you a small example for that so that you can understand it. Hmm. See, scale, like if I just try to tell you, like, scaling function, the scaling is something like, uh, okay. Now, say suppose you go and buy a shoe, right? You would have gone to purchase a shoe. So you might would have noticed that, on the shoe in the, shoe size are generally given in US and UK size, correct? So
Yes.
the shoe seller asks you, right? Will you like to, what is your shoe number? So you ask him whether you have the sizes in UK size or a US size. Now, many a times people do get confused, right? So because there is a slight difference, so 7 and 8, so maybe 7 is not the smallest in the US, but it is smallest in the UK. It is a smaller version in the UK. So what if we do is, if we remove US and UK and we define our own size like of small, medium and large. So because see US also will have some small size of shoes, the numbering will be starting from 6, whereas in the UK it is starting from 7. So both are the smallest size only, both are small shoes only. So that you do not get confused, like okay, which one is bigger and which one is smaller in US and UK. What if I do if I give them both the size as S? If I call them as S, don't you think it will be easier for you to understand that both are the small size of shoes, whether I'm buying US or UK, they both are of same size, right?
Yes.
So this is called as
Yeah.
scaling. So scaling means we are, kind of bringing the data onto the same scale so that we do not get confused that 6 out of 6 and 7, which is big or which is small, because technicality, from technical perspective, 6 and 7 are both the same size. It is just that in US we are representing it by the number 6, but in the UK we are representing the same thing by number 7. So I brought them to the same scale of 7, the smallest, as an S over here. Now, similarly, what happened in the data is, now in the data, what is happening is you have the information like this. You have age, which is like, uh, you know, 20, 25, and 30. You have salary, where salary is 30,000, 40,000, and 50,000. So now in this case, what is happening now is that this is the smallest age and this is the smallest salary. So don't you think if I just represent both of them by 1, I will be kind of saying that this is age and this is salary. So can I say this is the smallest age and this is the smallest salary that I have in my data? If I just represent it
Yes.
by some number, right? So similarly,
Yeah.
if I call this as 2 and this as 2, so I can understand that this is the second highest age and this is the second highest age. This is the third highest age, third highest salary. So this is exactly what scaling is. So you are You
Uh,
have replaced the
so
data.
it means we change the data in other data type, just similar with understanding for own study.
For the model to kind of relate to it. So that
Yeah.
model do not get confused that this is small number, this is big number. So we are bringing them onto the same scale.
Okay. So, I am applying scaling on a column. So it's give positive or negative values like 1 point something something.
Mhm.
So how it's backhand how is calculate?
See, basically what happen is, so scaling function is something that follows a formula. Okay. So there's a formula that is used. So what it does is, see, one thing is scaling can only be done on the continuous variable, right? So like age and salary.
Yes.
These are the variables. You cannot do a scaling on country, name, or something like that. A categorical variable, you cannot do the scaling on that. So technically, what happens is, like, if I just try to give you or define the
Mm,
formula. So the backend formula is basically what happens in the R is, in the case of scaling, the numbers are subtracted from the mean, right? So first the mean is calculated. Okay, so like the mean
okay.
of salary will be calculated. Then each number will be subtracted from that mean. Okay, and then
Mm,
it will be divided by the standard deviation.
okay.
Okay, so
Okay.
so whatever is the salary of, so have we seen this thing somewhere before? I am subtracting the salary, I'm from the mean, and then we are dividing it by standard deviation. Have we seen this thing before somewhere?
Yes, Z factor, I think.
Z score,
Z value, yeah, yeah, Z
right?
score.
The value of standardization, we
Yeah.
used to call it as the value of standardization, because everywhere we used to get a different, like we used to calculate standard deviations. So in order to standardize the data, what over there also we were standardizing the things. Scaling, that was also kind of a scaling only, right? Well, whether your standard deviation is coming as 100 or your standard deviation is coming as 1000, we were representing it by 1 sigma. So that was again scaling only, right? So
Yes.
suppose I have salary and I have age. Everywhere what is happening is you are having a different different big number. So we are bringing the standard deviation to the same scale. So that is the exact same thing that is happening over here as well.
Okay.
Got it? Now is it clear?
Yes. Yes.
Okay. Others, any question, any queries?
I have a question. So in logistic regression, I remember you had said that we can control the number of variables or vectors that we flow into the model,
Mhm.
and try and adjust the r square, or the one which is similar to r square, right? So why don't we do that similar thing for linear model as well?
So in the linear model,
Did
you doing the same thing only. No? Over there, you are getting R square values.
Yeah,
So
we are, but then we kind of categorize which are the vectors that we take and which are the ones that we should drop, right? When while we are calculating the score for the model.
no, I'm not getting a point. So basically, if you see, so in the linear regression, what happened is, say suppose I am creating a model between, say suppose I have two or three things with me. I have R&D spend, I have administration spend, admin, and I had the marketing spend.
Correct.
So we wanted to predict what will be the profit. So what we did over there
Mm,
was, so we created a model, and model gave us the
mm,
p values, right? We got the p values for each variable. Then what
right.
we were doing over there was, from that p values, whichever all the variables which had the value less than 0.05, we are
We consider
taking,
them.
we are considering them. And based upon that also, like whichever variable has the lowest value, that is considered as the value which is the most significant. Correct?
Hmm. Hmm.
The,
Yes.
Yeah, and the same p values we get in the logic regression also. So similar p
So
values
you're
we get.
saying that we're doing the same thing in logistic regression as well. So where we kind of any vector which gives a p-value more than 5.05, we kind of drop them from the
Correct.
model.
Yeah, because in the logic regression also, if you see, we were using linear equation only. It was just that because the output is in yes or no, like it's a binary binomial output that we get. So
Hmm.
output basically comes in the form of the probability, right? So if you remember, so it what we did was so that my output doesn't go below zero and more than one. So we applied some exponential and log functions on that same linear equation. So that is why, I mean, it is in the backend, technically it is linear regression only. So, and we are just controlling that output should not go outside zero or one.
Okay.
Yeah.
Okay. Got it. Thank you.
Okay. So Rishabh, you have a question. If I want to fetch the data from the image and website, so how do we do this? Now we just do this. So Rishabh, you first of all is like linear regression and logic regression that you think of. So basically you need the data in that, right? So the question that you are asking over here is it is about how to fetch the data. So that is
Oh,
if you have to fetch
yes.
the data from the website, so there is a technique that is called as web scraping. So it's an altogether a different, it's not that tough. You can learn web scraping easily. So with the web scraping, what you can do is you first of all grab the data from the different websites. So you can grab the data from Twitter, you can grab the data from, the Instagram, wherever you want. And then what you do is you have to again clean the data, right? You will have to structureize that data so that it comes in the proper tabular format. Once the data is in a proper tabular format, then only you will be able to apply a linear or logistic regression.
Yes. And also, I want to how to fetch the data from the image.
So for that, you will basically easily you will not be able to do it. This is something that you will have to learn a bit of AI for that. So with the help of AI, you will be
So
able to do it.
you will explain in this session in this both.
No, no. So that is the AI part is a different field. So this is over here you are learning machine in this training you are going for training of machine learning. AI is a different aspect. So basically, like if I give you an example, like you would have seen that there are the speed cameras that are installed on the roads and highways. So they all operate on that AI technique only. What happens is that any car that is going above the speed limit, that camera clicks the picture, and then from that picture the number of that car is extracted. So that is happening with the help of AI based algorithm. So we cannot, I mean, you need some cloud computing and other techniques in order to learn that up. So which is a little different field what we are right now into.
Okay, okay, okay. So I just want to know if we complete this session
Mhm.
and after I'm preparing for the placement, so company they needs this stuff AI or web scraping in.
See, there are very few companies. See, web scraping is, yes, it is used by a lot of companies, more like research companies, I would say, right? So
Yeah,
mostly
yeah.
the people who are into research, what they do is they make use of the web scraping, and web scraping is nothing big. It is just one single piece of code. You just have to change the name address of your website and run the code. It will extract that information from you. So it is not that difficult task.
Okay.
Even the like my
Yeah.
brother, he's into KPMG and he is into the deals and advisory. So he also has a similar kind of a task where he has to grab the companies, he has to grab the information about the different companies from their websites. So now he is a non-technical guy. He doesn't know Python. He doesn't know R, but the coder have given them a Python code and have guided them that how to run it. They simply change the name of the website and they run the code and they are able to extract the information. So it's just one single piece of code that is
Oh,
largely used everywhere.
okay. I was thinking is a big deal to me.
No, no, no. Web scraping is very easy. I mean, it's you have to just Within 1 hour, anyone can learn web scraping.
Okay. Thank you so much.
So, okay. I mean, there is a lot of stuff. I mean, if you will just start deep diving into this, data science, and what I feel is you also have that curiosity in terms of learning and exploring the things. Definitely, you can find a lot of things that you can explore. There is text mining that you can look out for, right? So, like, there is a lot of text analytics that happens in every industry. So, if you have a book of 1,000 words, definitely 1,000 pages, definitely you cannot read that book and spend 5 days, 10 days in reading that book. So you can use text mining technique wherein the code will tell you what the context of that book is. You can do text mining in order to grab the tweets, right? So for example, recently, now this is corona pandemic that is happening. You want to understand what are the sentiments of the people, like what people are feeling about this pandemic right now. So definitely what people do is they share their tweets. So you can fetch their tweets, and then you can write a code which will also analyze whether people are feeling good about it, feeling bad about it, or they are neutral about it. So there is a lot of stuff that happens around when it comes to data science. Okay, so with that, let us come back to this, the logistic regression, the thing that we were doing uh, in the last session that we were having. So now I would like to ask from you guys. So I guess I don't see many of the answers over here, like the people who would have tried this code. Okay, so like in the last session we had done up till the part of the EDA part, right? So I just we were onto the verge of creating the model, but we didn't do it. So I will just run that code up till that point. Okay, so if anyone has any doubts, please let me know on any part of the code. Okay, so we counted the rows and columns, column names, structure, and also this is basic stuff that we were doing. Then we converted various columns to levels. We converted the columns to factors, right? We converted them into the levels by using the apply function. So then what we did was we started the renaming of the variable, right? So I think this is also something that we did in the last part. We renamed male and female. So please, let you can all feel free to ask if you have any queries or doubts. So, right, so we renamed the qualifications, and then we were shuffling the data set. So I guess this is the part from where we had to do the stuff, right? I guess up till this academic qualification, this was a small, quick case study that we were doing. Now over here, this was the part from where we had to break the data into test and train, and then build our model on top of that. Okay. So now, how we have learned to break the data set is, see, for doing anything to everything in the R, there are multiple ways. Okay, so like in R, uh, you all would have seen we have similar kind of a functions in different packages which give us the same kind of a result, right? Now, similarly, to break the data also, to break the data set into test and train. So one technique that we learned was using the CA tools, right? This was something that we learned, that we can use a CA tools package in order to split the data into test and train. Similarly, there is one more package that can actually help us to break the data into test and train. So it is totally your choice, your comfort level, what you feel is better. You can go with that. So there is another technique that is called as, there is another package, and the name of the package is Carrot. Okay. So there is a package, this is carrot package, which you can use. Again, this package is used to break the data into test and train. Okay, this is how this same package is used for the similar kind of functionality. It is just that it is the function that we will be using over here, they will be just applied a little different way, right? I mean, the idea will remain the same, but the way we will be doing the same thing will be little different because each package has its own function. So we will be using the function dedicatedly or provided to us in that library. So how do we do it? First of all, what I am doing over here is, so we are creating a variable by the name of group. Okay, see, how do we actually break the data type into test and train? So tell me, what is the approach that we follow if I give you all a data set and I ask you to break it into test and train? How will you do it? Okay, so you say sample dot split. Now what is the role of sample dot split? Sample dot split is something where we define that in what order do I want to split the data, right? Like 70-30 ratio, 60-40 ratio, 80-20 ratio. That is where I define that ratio when I'm using the when I'm using the sample dot split. Okay, this is something that we do. But before that, we do something. Even before we go to the sample dot split, do we do something? We set the seed, right, Raghu? What we do is we do set dot seed. Why do we do the set dot seed? Okay, so you said to fix the sample. Okay, what else?
Actually, say if you are generating a random number, we should also be getting the same numbers.
Just give me 2 minutes. Okay. See, the idea remains over here that we have to break the data set into a random way. Okay, that is my first requirement. Okay, that is what we do. Say, for example, if I am given a data set, say, suppose I have some age and salary, right? I'll take just this data set. What will happen is if I will say, okay, let me keep the first two rows in the training and the last one in the test. So what is happening over here is in the training dataset, I have only included the people who have young age and lower salary. And in the test, I am testing the model on the data which has, I am testing the data on those people who have high age and high salary. So somewhere the data set that I have created to create my model is not, I will say biased, right? Because it only has the people of younger age or a lower salary, but I'm testing it on the people who have high age and high salary. So because we never know, right? Because when you will be working on the data set, you will get the data sets with millions of rows, and it will not be possible for you to understand that how that data is, created or in what order that data is. So what we do is we basically shuffle that data. When you say set dot seed, so what you do is you tell R that pick the rows from there randomly, and definitely that number that you put over here, that fixes that thing. But the main objective is you want to pick the number of rows from there that that is randomly. It should not happen that it picks up the initial starting first rows for the training data set and the last remaining one for the test. So that is why what we do is we say just pick randomly two rows. So it might pick this row and this row. So that way what will happen is the model will learn from the data where people are of younger age and lower salary plus older age and older salary, and then it will be able to give better predictions also. Got the point that why that shuffling is done? So we first shuffle the data set, and then what I do is I pick up the test and training data set from there. Am I making sense to all of you? Okay. Now the same concept we will be doing over here in the carrot, using the carrot also. So what we do over here is we first of all do one thing. We create, what we do is we create a variable. In that variable, I am just generating some uniform numbers. Okay, so I am generating some uniform numbers. And how many numbers I am generating? I am generating the numbers equal to number of rows that I have in the data. Okay, so this is what I am doing over here. So we are using runif function. So if anyone doesn't know it, say suppose I say runif. Runif stands for random uniform numbers. So I am saying runif 5. This will generate 5 uniform numbers for me. See, it generates 5 uniform numbers for me. And the order is not fixed. You can have bigger number before, then a smaller number, then again a smaller number, then a bigger number, then a smaller number. So it is a uniform number that you are generating over here. Okay, this is the use of runif function. Now what I am doing is I am saying that let's generate uniform numbers and save all those numbers in a variable by the name grp group. Okay, so let us do that. So if you will now notice, we have created a variable which has it has some random numbers in it equal to the number of rows that we have in this data set. Okay, so what I've done is I have created a variable in which I have generated uniform numbers inside this equal to number of rows that I have in my data. Then I am shuffling my data set. I am saying let me shuffle this data set. Let me shuffle this data set on the basis of the numbers that I have generated. Yeah, plus, are you getting it? What I'm trying to say? See, what I'm doing is I had this data with me. I generate some numbers over here 3, 2, 1. So maybe I'll generate in this way 2, 1, 3. So I randomly generate numbers, and then what I'm doing is I am saying let me sort the data on the basis of this. So whatever the numbers are coming over here, I would like to sort this data on the basis of this. So this is exactly what we have done over here. What we have done is I am saying I have created that variable, and then I'm saying let me order the data on the basis of these numbers that I have generated. So I have shuffled my data set. I have done the shuffling of my data set over here. Okay. Now after that shuffling of the data set is done, now you all have to install a package of Carrot, put it into the library, and you just define your partition. How do you want to break the data? So you want to break the data into 70-30 ratio. So you will say create data partition. This is the data set on the basis of default payment. Break the data in what percentage? 0.7, right? So 70% data will go in the train and 30% data will go in the test. Okay, so this is how you can create your test and train dataset with the help of Carrot as well. So you say create partition, you give the name of your dataset, you define the probability, the percentage, and that's it. And you say list equal to false. This is just a function that you say list equal to false, and then you can check the number of rows that you will be having inside this. All of you, please try this out. Are you all able to understand it? What is written over here? Yep, so I will also put this over here on the chat also in case if you would like to take it up from there. So Bhuvneshwar, it is not different. I mean, just the functions are different. Classes, give me one moment, right? Hello. Sorry guys, there was some background noise that was there, so just had to take a pause. Okay. Okay. See, basically, Bhuvneshwar, like the question that you're asking over here is like, what is the main difference between sample dot split and create data partition? Okay. See, if you remember, like we did one of the package that was dplyr. Okay. Now in the dplyr also, if you remember, there was a function that was sample underscore n. Right? We have a function over there, sample underscore n. What that function will do is that is also something. Let me just put this package into the library dplyr. Okay, so over there also we have a function that is sample underscore n. If you use that function, what is the use of this function? You give any data set. If I give the data set as this only, bank df underscore bank, if I give this data set only and I say I want to pick 3500 random rows. Okay, so what will happen in that case is it will pick 3500 rows of data but randomly. Okay, it will pick these many number of rows randomly. So technically these are just the different functions that you have which are doing the similar kind of a the thing. So create data partition, if you will check this out, if I will say create data partition, now this function that you see is coming from caret package. Okay, you see it is written a series of test or training partitions are created using this, right? If you just read this little the description that is given, it is used to again make your test and training partitions. Similarly, when you if you have library of CA tools, right? If you have this with you, and now if you write a function that is sample.split, now this function is something that is coming from CA tools package. Now sample takes, now this sample, what this function does is it takes a sample of the specified size from the elements of X using either with or without the replacement. So it is just the similar kind of a functions coming from the different packages. Okay, right? So it's basically like, you can send a message using the WhatsApp also, you can send the message using a hike also, right? They both are the similar thing, but WhatsApp will have its own different interface, hike will have its own interface, but the ultimately the goal will remain the same, the goal will be the same. So that is the same thing that is happening over here as well. We have two different packages and both are offering the similar kind of a functionality for which we have different functions. Am I making sense? Right? So that is exactly the same thing that is happening over here. So we are saying, okay, we install this package of caret, and from there, now instead of using create partition, right, what I'm doing now is I am using my function create data partition. I am specifying my data set, then I'm defining I'm defining the percentage on which how much data I want to keep in that training data set, right? So first of all, I have created a variable train rows, and I am saying 70% of the rows will go inside this. So let me show you this. I run this. Let us see what kind of a data do I have in the train.rows. So it says it will keep the initial 70% of the rows, which are these, and then we are saying we create a training data set in which we are keeping how many rows? The one that are coming over here, that we are keeping in. So this is like subset, right? First we used to create sample.split, which used to give us true and false. Then we used to say create a subset where sample.split is equals to true, right? That is the thing that we used to do. So same is the concept that we are doing over here as well. So first of all, we are creating the partition, and then we are defining that these number of rows we want in this training data set. We run this, and similarly we create the test rows. In this, what we do is we keep the 30% of the rows, which are the remaining 30% rows. Then I create this over here, and similarly I create the test data. So that is how you will be creating your training and test data sets. Yes, yes, Sakshi. So there is a possibility that you might have some data that might get repeated over there. Yeah, it is fine. I mean, it is totally fine. So even if there is some bit of an overlapping that happens, so that is fine. Okay. So now test and train data set is created. Now we will build the model, right? So now we will be building the model over here. So let us build this. So we know we will use a GLM function for that. And how we will create it, how we will create our model. We will say, I want to build my model equal to, we will be using GLM function. So what is the command? Who will tell me? What is the command that we write? Formula is equals to, what do I have to predict? So my formula will be default, right, Ashutosh? So we will have default, dependent default underscore payment, default underscore payment is dependent on all the variables, comma, we define something over here. What is that? Class, right? Family equal to binomial, and then we do, what we do is, first this is defined, then we say data equals to train. So in this case, the name of the data is data set is train.data. So train dot, I mean, if you have named it as train, so that is also fine. I have named it as train.data. So let us build the model. So the model is created, and now what we will be doing is, we will be checking the model over here. Okay, so we will see what is the model telling us. So we will say summary of the model. Okay, so we have created this, and let us see which variables are coming significant and which are not. So we can see there were a lot of variables that we had, right? So we had around 21, 27, 22 variables with us, correct? So we can see which all variables are coming significant. So intercept is coming significant. We have credit amount, we have gender, male or female, academic qualification is coming significant. Then we have the repayment status that is coming as significant. Okay, so these are the things that are coming significant over here. So what you will now do is, you will only keep the significant variables and recreate the model. All of you, please create this model and check out the summary by yourself. Please spend 2 minutes on this. So Raghu, you are having, just check the spellings once, so spellings are also correct. So it should not happen. I mean, yes, the spelling and everything is correct. So for training, is it working? So you have shared the code of test over here. So for train, did it work? So sorry, sir. So Sakshi, is it possible you can share your screen? Maybe I'll be able to help you better. If you can just share your screen, maybe I'll be help you better in that case. Okay, so you can't. Okay, sure. I'll just make you the presenter. Just give me a moment. Mm. Sorry. Yeah, I can see it. Yes, yes. So error in create data partition. Can you just type in over here? Just hit enter and start writing create data partition from the starting. Just hit enter on this line. Yeah. Now write this. Oh, this function is not coming, right? So I think you just need to install this caret once again, right? Just install this package caret again. So this package is either not properly installed or something has happened. Yeah, I can see it. Sometimes it happens that the package, when they are not properly installed, the names come up, but their functions are still not available. So remove it from the library once, uncheck it from here, uncheck the library, uncheck the tick mark. Yeah, uncheck that. Okay. Now check it again. Okay, so you can write, I mean, maybe you can install it again, install the package again, caret, and then let's see if it is working fine or not. So Bhuvnesh, did it work for you when you reinstall it again? Yeah. Yeah, it's a caret with a small c. Yep. So the pack spellings are correct, Sakshi. So that is correct. Just install it again. Uh, One second. Strange. It's giving this error to you. Can you just copy and send this? This to me. Error in this. List equal to false. Could not find the function. Yeah, please send that error to me. That while installation, you have got one error. If you can just send that error to me, I'll just take a look at it. Okay, I'll just take a look at it, Sakshi. In the meantime, and let me give other people a small task so that they can just do it in the meantime. Okay, so first, did you all create a summary of this? And so Sakshi, what you can do is, in the meantime, if this caret is not working, create that train and test data set using the CA tools. I guess that is working, so that you do not go you're not left behind. So do it with the help of CA tools. So by that you will at least have the training and test data sets. You will be also be able to build the model parallelly with us. Okay, so you have to just say sample.split. You will first create a variable split equal to sample.split. You will say your df underscore bank dollar, right? Oh, okay. So sorry. So you can do that, right? So once you create it, right? So guys, are you all able to uh, understand like what is happening over here, right, Bhuvneshri? Like you were asking in the starting. So here we have these p values, right? So this was the z score. Based on the z score, we have got the p values. So the same z-score, right? The on which we did that all that stuff of hypothesis testing. Correct. This is the same z-scores on the basis of which the p-values are getting calculated. Now R is automatically telling me which variables are coming significant. So I can see credit amount is significant. Now if you see, now let's again come back to that concept of logical thinking. So it's make a lot of sense that if I am giving someone a loan, so if I'm giving someone a loan of smaller amount versus I'm giving someone a loan of higher amount. So amount will play a significant role in terms whether a person will default or not. If I'll give a loan of smaller amount, so there are less chances the person will default. If I'll give a loan of higher amount, there are high chances the person will might default. Correct? We can see gender is playing a role, right? So male versus female. So gender is also playing a role. Maybe male are not paying on time, or maybe females are not paying on time. So gender is playing a role over here. So we can see qualification is also important. So like the professionals. So in terms of professionals, there is a significant effect that has been seen that either the professionals are not paying it or they are paying it. I mean, they are either making a default or they are not making a default. So I can see qualification is also a important variable in terms whether a person will pay or not. The marital status is also again important. Age is important. Then some of the variables others that are come. So repayment status of Jan 5 and 6. So repayment status is also coming as important for Jan and Feb, for March also. And yep, so kind of we see these are the variables that are wherever we see the stars coming up, so those are the variables that are coming as significant. So bill payments are not coming as that much significant. I can see that March bill, May bill, these are not that much significant, but rest of the variables are important. So what I've done over here is I have recreated the model by using only those variables which are coming as significant. Okay, so now we are using only those variables and just recreating the model again. And we do it and we create, oops. So we create this model again. Yep, so here we are. So let us create this variable again, a model again. We can see the summary, and in the summary now all the variables should be coming as significant. So April is still coming insignificant, so we can remove the April payment also. So it doesn't make sense to keep that. And then likewise we have all the variables. Okay, so I just kept the significant variables now. So in the model, instead of keeping all the variables, I am saying let us recreate the model with significant variables only. So Rishabh, what is the value that you're getting? What is the p value that you're getting for the age? And what is the partition that you have taken?
75%.
Technically, it should not happen. I mean, age should be coming as significant. Just try to recreate it one more time.
Uh, okay. With 75% or 70%.
You can take anyone, 70 also, 75 also.
Okay, I'll do.
Okay. So degree of freedom, yes. So see, degree of freedoms are basically Ashutosh. See, this is what the formula for degree of freedom is. Okay. Degree of freedom means number of rows minus k minus 1. What is k over here? K is called as the number of predictor variables that you are using. Okay. Say suppose I have 1000 rows of data with me and I am using 5 predictor variable. So what will be my degree of freedoms? Degree of freedoms will be 1000 minus 5 minus 1. That gives me 9994. Okay, that is called as degree of freedom. So degree of freedom means how many values are can be used freely inside that data set. Okay, so this is something that is called as degree of freedom. So the number of points that you have, like if I was like I explained you in the last session, we discussed this thing in the previous session as well. So if you have 2 points, now these 2 points can only be connected in this way. There is only one connection that you can have between the two. Okay, and if there is one more point, so these 2 points, this can be connected to this, or this you can connect it to this. So basically what you are saying is how many values are something that can be used freely inside the data that is given, that is called as degree of freedom. And this is what the variable, the so Raghu, not the variables, it is the rows. Variables are something that we are using over here, defining by the term k over here. So right, like if you will see in this data set right now, so in the training data set, how many rows did we had? So let me just tell you, number of number of rows in train data, we had 21,001, these many rows. And how many columns do we have? In 25. Okay, so 21,001 minus 25 minus 1. So 20975. Mhm. So this is this 209 97057. How many counts did we had? I'll just get back to you on this because the formula that I'm using is correct over here. So why is it giving me this? I'll just get back to you on this, right? Okay. So now, if you will see over here, now what is happening in this is basically, so Bhuvneshwari, as you mentioned, so the residual deviance. So this is something that we discussed in the last session that we had. So first of all, who will tell me like what is null deviance and what is residual deviance? What are these two terms? What is null deviance and what is the residual deviance? What are these two things? Yep, anyone who remembers this? Right, Sakshi. So basically, null deviance is what when you try to predict the values just using the intercept and not using any variables. So what is the deviation that you get in that model from the correct results? That is called as null deviance. And residual deviance is when you start taking the variables in it. So basically, how that the predictions are getting better. So what should happen is your residual deviance should be as low as possible, right? As much low as your null deviance could residual deviance could be. It is the better the predictability of your model will be, right, Raghu? If this will increase, so that means the accuracy of your model will decrease. So if we just try to see this over here, so right now it is 18461, and if I compare it with the previous one, so what was the value in that case? It is still the same 18423 only. This is the same that I'm getting over here also. 18423 and 18460. So it has increased basically. Yeah. So a very slight increase that has happened over here. Not a problem. So over here, what we see right now is this previous payment April is something that is not coming as significant. Okay. So let me do one thing in the model over here. Let us remove this previous payment, right? So let us remove this. Now let us try to create the model again and let us see what is this model telling me. Okay, so let us see the summary. So still it remains the same 18464, right? So it was previously 18423, and let me check out the variables which are coming as significant and which are not. So this is significant. Repayment status June is significant. Repayment status May, okay, April. March is also significant. Kind of all of them are coming as significant. Yeah. So maybe if you see there is a very 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 slight change that is coming. It is not a very big difference that is coming. So either you can use all the variables or you build the model with the same the selected variables also. It should not be a big difference that you should be getting in the output. Okay. Now once this is done, we will predict the data, right? So we will start predicting the data over here. So how do we predict the results? So we use a function predict, right? We use our model that we have created, and then we have to just add one function that is type equals to response. Response means that the output should come in the form of probability. So class, please predict the results. Let's make the predictions, and then we will save. We will update this data with, if the value is less than equal to 0.5, we update it with 0, otherwise 1. And then what you can do is you can create a you can add this data set into your test data set, and please let me know the accuracy of your data model that you have created. It's plus anyone who has calculated the accuracy of this data set. Okay. So right below my face, so this is the confusion matrix that we have created. So we will add that data. So prediction full model, if else 0 to 1, we change it. And then what I will do is I will add this column into my test data set. So test dollar predictions equal to prediction underscore full model prediction underscore full model. So this is test dot. So we have it now. So let us check this out. Test dot data. So default payment and predictions. So we have the two things. Now what I will do is I will create my confusion matrix. So I will say table. In the rows, I would like to keep test dot data dollar confusion or the default payment, comma test dot data dollar. What was the name of the predictions? Correct. So this is what we are getting, 0 to 0 and 1 to 1. So let us try to add them up. What is the number that we get? So accuracy will come as 6628 plus 705 divided by, you will get divided by this 6628 plus 705 plus 322 plus 1286. So you're getting an accuracy, we are getting an accuracy of 82% over here. If I create this, so this is what we get as an accuracy. Are you able to create it? This accuracy, are you able to calculate it? There is one function also, I was just exploring that. There is one function that is diagonal. As there is function that is this table function that we use. Let me just try to use that. We have prop.table. So this is one function that you have, right? You can, let me just try this out. If I'll pass this over here, test dot data dollar this proportion dot table, and let me use this over this. Yeah, so this is what I was saying, right? So if you see, this is the something, if you will use proportion dot table. Okay, now this is also an interesting function that I think you can all try to use this also. See, when you use this table function, right, table function is something that will give you the count. How many 0 to 0 do you have? How many 0 and 1 do you have? 1 and 0, and likewise. If you will put that entire function, inside one more function, that is proportion.table. Okay, that function is prop.table, proportion. What that will do is, it will give you the output in the form of a percentage. You will not have to go into the hassles of adding that up by yourself. If you will say 74 plus this the 7.8, it is coming somewhere similar to 82. So the exact same number you can just calculate from here also. So the thing that I've calculated by here, by putting this into this, it is far more easy for me to just add these two numbers. Getting it? So prop means proportion. Like, what is this? This number is count of this number divided by overall total. This is this number divided by the overall total. So you're given the percentage. And then on top of this, what you can do is you can wrap it around in one more function, that is diagonal. So diagonal function, what this does is it adds the numbers diagonally. Now, it shows you the diagonal numbers, and you will have to just wrap this around in this sum also. Just a trick, right? So just some more tricks on this. So you can just add this up. So you get the same number. Getting it? What I've done? So first of all, I have wrapped the table function inside the proportion table. Then I'm saying just pick up the diagonal values. So diagonal values are this value and this value. So I'm picking up the diagonal values over here, and then I'm summing it up. I'm summing up the diagonal values. So I get the percentage from there as well, the accuracy. Okay. So then what you have is So what is the issue, Rishabh? I'm sorry. According to my model, I will create, but some is wrong.
I'm asking about I'm creating my model with 70%, and according to me, age of year is not a significant variable. I'm checking my summary of the model. So according to this, I will create the model for all the significance variable. So it's give me an error. The object gender female not found.
Object gender female not found.
Yeah, gender female is also a significant variable.
No. Can you share your screen if possible?
Yeah, sure.
Huh.
Amit, again is need to get a permission so I can rejoin the Google meeting. Hello.
Yeah, I've made you the presenter, so I've given you the permission.
Yeah, yeah. Just a minute. I will quiet this Google meeting and again join.
Okay. So class, anyone else having any questions on this up till here? Are we all sorted on this? So Baldev, you want the code from which part? This one, right? So what I see, no one is having any question. Okay, prediction part also I can do it. So I'm doing it from here. Yep. So I'm just giving you the complete portion up till here now. Please, just all of you, please walk through it once. So still, if you feel that there is any section of the code that is not clear to any one of you, please feel free to ask. So all of you, please tell me how many true positive values do we have? So how many true positive values do we have? Okay. So Bhunesh, you say 665. Anyone else? Any other answer on this? Yeah. Just give me 2 minutes, right? I'll just take a look at your screen. Just give me 2 minutes. See, what is true and false? How do we represent that? True and false. Right? So true is represented by 1 and false is something that is represented by 0. So if you will take a look at your the table that you have created, right? So if you will all take a look at that. So if you take a look at this over here, so basically let us take a look at this table, which has actually 0 and 1. So is this the true positive or is this the true positive? No. So true positive will be this 705. So this is the value that is true positive. See 0 and 1. So basically that a person over here 1 means that he will make a default, right? And 0 means no, not a default payment, but 1 means yes, he has made a default payment. So what we are actually testing out for, we are testing out whether a person will make a default or he will not, right? So when you conduct a test, what do you check? Whether a person has a disease or he doesn't have the disease. So that is something that is called as your, the positive and negative. You are looking out for a disease. If you catch the disease, that means the test is positive. Otherwise the test is negative. Now the same is the thing that is happening over here. So this is, so you just try to keep it in mind with 1 is your positive and 0 is your negative. So this is your true positive number. Okay. So you have 705 as true positive. And if I ask you guys now, like what is the false positive? How many false positive do I have? Correct, Rishabh? So you have 322, which is your false positive. So if I ask you that how many, the positive values are coming correctly, right? If I ask you that what is the percentage of the positive values that you are getting which are coming as correctly, so how will you give me that output? Maybe I need to reframe my question. Maybe uh, so technically, no, I should not frame it that way. I'm just trying to create the question. I frame a question. Just this is a little tricky question that I'm trying to ask, which is asked a lot in the interviews. So I'm just trying to ask from that perspective. Uh, okay. See, let me ask you something that so I want to calculate something in that context, that how my basically formula is able, how sensitive my model is, right? So how sensitive my model is something that I want to ask from you. Like, this is something in the context of, the this is something that is used a lot in the context of the medical, the industry, right? Over there, there are some terms that are used. Sensitivity. Okay, we use the some terms like specificity. So sensitivity and specificity, these are two terms that are used very a lot in the pharma industry. So what exactly do we mean by this? What is sensitivity and what is specificity? So I just wanted to frame a question on that so that you can all kind of could get an answer, or just get the correct kind of a question for you guys on this. So that is what I was trying to formulate into my mind. So basically, the sensitivity is that how sensitive your test is, and it is calculated, right? So sensitivity is something that is calculated as the formula for sensitivity is true positive, right? True positive divided by your true positive plus false negative, right? So this is something that is called as sensitivity. That how many times it positively treated divided by true positive plus false negatives. So can you calculate that? Can you calculate the sensitivity now? I have given you a formula that how sensitive your model is. So in how many cases it gave true positive result, which is divided by, and the sensitivity is given as true positive divided by true positive plus false negative. And this is something that is also called as this is also something that's called as true positive rate. So another name for this, true positive rate. So this is another name for this. Can you tell me what is that sensitivity coming? I think Baldev, you have done the division the opposite way. At the top you have true positives. So true positive is this 705, right? So if you have to calculate it, 705 divided by 705 plus what I will add in this false negative. What is the false negative? Right, 1286. Right, so we are getting approximately a sensitivity of 36%. So this is sensitivity. Then same way you have specificity. Specificity is, if you will just try to see this, specificity is just a opposite of that, right? So just the opposite of so you are still not getting true positive. Let me just show you that, Ashutosh. I think the best way is always that that we have is the diffusion matrix diagram. So this is the way you can always remember it. This is a little confusing. Right? So you can see it from here, or you can see this also, right? So you have the actual values over here and the predictive 0 and 1, right? So but basically what is happening in my diagram is, if you see, positive is something that is called as true, right? So these three words are very much similar to each other. You can call it as true, positive, or 1. They are the same thing. These are the same thing. False, negative, 0. These are the same things. Okay. So how is my table? So my table, the table that we have created, okay, the table that we have created, our table is something like this. We have 4 values. This is 0 and 1. This is 0 and 1. 1 means true, 1 means true, right? So this value is true positive. So in the data also it was true, and my model has also considered, given the output as true. That is called as true positive. Okay. And this value that you see over here, what will be this? So these are the, at the top you have predicted values, and on the left hand side you have the actual values. Okay. Now prediction was 0, but in the data it was 1. So what will be this? This will be false, positive, sorry, false, negative. Correct? False, negative, because my, in the, basically the, my model has predicted it as negative, but in the actual data it was true. So this is false negative. This will be what? False positive, and this will be true negative. Got it? Right. So these are the numbers that you have to now divide. So for sensitivity you had to divide this number by sum of these two numbers. And in a similar fashion, you can calculate the specificity. So specificity, what is the formula for that? For specificity, we have the formula as, specificity is, it is the false negative divided by, right? Oh, sorry, true negative. Sorry. True negative divided by, we have this true negative plus false negative. This is called as sense specificity. Right? These are now, these are terms which are more intensely used in the field of medical industry. But we should be knowing about them, that because these are the formulas that are coming from the true positive, false negatives only. So nothing much is changing in this case. Okay. So can you calculate this? So Ashutosh, now I will like to hear the answer from you. What is the specificity that you are getting? Others? Surya, Sakshi, Sahil, Raghav, all of you please calculate the specificity now. Bhavani, Okay, Sahil, so getting 83%. So, so there could be slight difference in the values that you may have. It should not be very drastic difference that you should be getting, because if that will happen, the accuracy will also be different. So, what is the accuracy that you are getting? So, what is true negative? So, true negative is something that you have it over here, right? So, you have the true negatives on this side. So, what were the numbers? Now, yes, Bhuvnesh, this should be true negative, right? This is the same thing. I was taking a look at that there is something that I've mentioned it as wrong in this. Right? This is the same thing that I was looking at. That this FP is not. This is basically true negative. Correct, right? True negative means you have predicted the negative values in a true way, right? So this is true negative. And what is this? If I see over here, this is the this is 0 and this value becomes 0 and 1. So actual was 0, but you have predicted as 1. So this becomes false positive, right? So I just give written these two terms together, right? That is a false positive that I have given. Yeah, I've been using this confusion matrix for years now, and still, I always get very confused in this stuff. So, in fact, I show you a small diagram of this in order to explain you. It's a funny diagram. I mean, I just, actually, I was preparing some stuff for the slides. So I got it. I thought I'll just share that up with you. Right. So see, this is basically what a true matrix looks like, right? So this is what that example is. So you use some basic terminology: true positive, true negative, false positive, false negative, right? So you can see this from here. So actual and predicted, no and no, true negative, right? So this is a true negative that the data was negative, the answer was in negative. So my model also did the same thing. This is false positive, right? So my false means, see, just try to I generally try to remember it by the term like false means कि मैंने गलत आंसर दिया है पॉजिटिव के लिए, right? I have given a wrong answer for that positive. So the positive that I'm giving. So example of this was, right, I just created that. See, false positive. So a doctor is checking a guy and he checks him and he tells the guy that you are pregnant. And false negative, the lady to her the doctor is saying that you are not pregnant, right? So this is something that we called it false positive and false negative. So this guy, he got a positive result when he went for a test of pregnancy, right? Which is not possible. So this is false positive. So the result was given positive, but which was false. And in the another case, the lady is pregnant, but the test came out to be that she is not pregnant. So the negative result that has come out, it is false. Okay. So maybe if this example helps you to remember the thing. I mean, please you can go by this. So how much is the specificity that we are getting now? Now can you all tell me? So true negative. So true negative is this was the value. So 6688, right? 6688 divided by true negative that is again 6688 plus I have to add false negative, right? So what are the false negative? So these are the actual, that is false negative, that will be again gone wrong. 128 false, yeah, 1286, 1286, correct. So 83%, right? So we're getting a specificity of 83%. So this is how you can calculate these two things. So sensitivity is called as true positive rate and specificity is called as false positive rate. So these two terms can be really helpful for you to keep in mind. So you just have to make sure that the formulas are you have to keep the formulas in mind, and that way you can easily calculate the sensitivity and specificity of the data. Okay guys, so class, this is where we come to an end on to the part of logistic regression. Okay, and for the session also today, right? So we have the session up till 10 only. So we will be here. So, and tomorrow also, we will be having a 2 hour of session, due to this some stuff that is going around. So we have to keep this session short, and because I'm not available for the next half of the day, so that the next batch do not miss their classes. So I have accommodated the 2 batches this way for this weekend. Okay, but next weekend you will be having the 4-hour classes only.
Amit, actually, I have not created my model.
Okay, sorry, you have to share your screen, right? Yeah, so
Yeah.
I'll just make you the presenter. Yes. So guys, are you all, did anyone work on the Titanic dataset in the meantime? I just wanted to ask.
I'm working on it, but I'm saying there is a mistake. You show my screen?
You can share your screen now.
You see my screen right now?
No, no. So Raghu, you want the code of this bank payment? That's this bank one that we have done. Yeah, I'll just put it right away. And but are you clear on that codes that we have written? Are you clear on every code? Because that is more important. If I will share the code. If in case you get any doubt on any of the code, please feel free to ask. So yes, like age is a no, Rishabh, I don't see your screen yet. So yes, like like age is a continuous variable, right? So age is a continuous variable. So what you will do is first create a histogram on that variable. Okay, first of all, create a histogram and test if the age is okay. First of all, check whether the age is normally distributed or it is skewed. Okay, if the distribution is normal, you can replace it with mean. If you think the data is little skewed, yet you have more of young people or you have more of senior people, you can replace the blank values with median. Okay, so this is the concept that we follow. If the data is normally distributed for that variable, we replace it with median. Else, we replace it with if the data is normally distributed, we replace it with mean. Otherwise, median.
Hi, Amit.
Actually, I have created the model, that model, the bank credit card, but that is too far from your model. Actually, I'm not doing practical right now because my laptop is not working right now. So even I have created on some GREA, GPA values also, my model on GRE, GPA values, like an examination values for exams. I have created it from take it from a website.
Okay.
Okay, but that create data lab like I have not understand some kind of functions like lappy, the apply, L apply.
Huh.
Send a as apply, but I don't understand apply.
So because I remember that last time I created a list for you guys, this, right? So I will be
Yeah,
taking
yeah.
a session for the apply functions. Okay, this is something that I will explain you. So apply functions, see, if I have to explain you in a very single line, one term, apply function is a there is, let me mute you please. See, apply function is just a substitute of loops. Just right now, keep this thing in the mind. You will not get confused. जहाँ पे भी आपको लूप लगाना है आप उसकी जगह पे अप्लाई फंक्शंस भी यूज कर सकते हो. It's just a substitute of that, right? If you will see, wherever we have applied the apply function, wherever we have used apply functions, okay, let me show you this thing to see this much. So what my requirement was, I wanted to convert, I had a lot of variables with me. My requirement was I had to convert all these variables in the form of a factor. Okay, so if I will do this thing with the help of a loop, I will write something like this: for I equal to 1 to n, where n means number of columns that I have. Then what my loop will do is it will pick each variable one by one and convert that into a factor. The same thing is what apply will do. In the apply function, I am saying pick up all these columns and convert them into factor. So apply functions are nothing. They are just a substitute of a loop. And in the apply functions, we have the functions like lapply, we have sapply, right? If you see over here, lapply you have sapply, right? And you have a simple apply function as well. So these are different
Screen
functions.
is not. Screen is not working.
Oh, sorry. Oh, sorry. Actually, I made. Sorry. So if you see over here, what does apply function do is it basically is just a replication of a loop. So what my requirement was, I had a lot of variables with me. I wanted to convert all these variables in the form of a factor. They are character data. I just wanted to convert them into a factor. So what I did was I simply used lapply. I said pick up all the columns from this data set and convert them into a factor. Otherwise, I would have to write a for loop, right? I would have written something like this: for I in number of rows that you have, number of rows that you are having in your data set. Then you would have written something like this over here, your logic, that pick each column and convert that into the form of as dot factor. So instead of going into that way, I have used this concept of apply family. So apply functions are of different types. One is lapply, sapply, and apply. Lapply is a function that works on the list. Sapply also works on the list. Apply function works on the array and it can work on the matrix also. So they are just different in the way on what kind of data structures you can use them, but the functionality of all the apply function is same. So I will be taking a session as well in order to give some examples so that we can take, you all can see the examples of apply functions. Got it?
I got it. And please upload this video as soon as possible.
Sure. I'll do it.
So that I can be able to.
Yep. So Rishabh, are you sharing your screen? I think I made you the presenter. You were not able to do it.
I'm trying, but again, yeah,
Uh-huh.
you show my screen.
I made you the
Yeah,
presenter.
you
I made
see,
you the
yeah.
presenter. Yes, yes. But I cannot see the screen right now. I cannot see your screen right now.
I'm showing. There is a show option. I will select the R Studio.
No, nothing is useful. Is it visible to anyone else? Maybe if not a problem at my end.
Uh, can I give you the controls of my mouse?
No, so till the time, Rishabh, your screen will not be visible. So I will not be able to take the control because since I
But
won't be able to see your screen.
uh, just a second. I will again try. It's not working. Actually, it's updated, so there is some new. I don't understand.
So do one thing, just share your code to me over the chat, over the mail, or over the chat also. Because right now I'm short of time, so I might not be able to, spend a lot of time on your query. Maybe what you can do is, if you can park this question
I'll.
for tomorrow, maybe I can
Oh,
take a look at the tomorrow because
oh,
I
oh,
then have to start this next session. So I'll just get a delayed
okay,
email
okay,
for that, right?
okay. So tomorrow, firstly, you will solve my query, and just
Definitely. First thing I will take your query and then we'll move forward. Then we will move forward.
okay, okay. Thank you so much.
Okay, and others, please work on that Titanic data set. And I'm uploading this code of bank default payment right away on that LMS. I mean, not on the LMS, on the Google Drive. Okay, guys? Okay, so see you all tomorrow. Until then, take care. Bye. Thank you all.